chessboards and I don't know, it's some form of grain and some form of board with some squares on it. That's what matters. So the story goes that there was a great sultan who got very upset because his son had gone off to a war and died. He was very upset. So his wise man was like, well, you're not ruling the country very well, you need cheering up. So he invented chess. Obviously the best way to minimise all frustration. So the king was very pleased with chess, he quite liked it, he thought it was interesting, and he said to this wise man, how can I pay you back? Ask me for anything and I'll give it to you. And the wise man said, okay, give me this chessboard, but with 1 grain of rice on the first square, 2 on the next, 4 on the next, 8 on the next, until all the squares are filled with rice. And so, I was at the problem on my first day of year 9 maths, and I was very excited because I knew the answer. It was great, I was going to do it. But I ended up arguing with my maths teacher, and this is why. So, can you see this? Good. So if you have 1 square on the first, 2 on the next, 4 on the next, 8 on the next. By here, when I was writing this, I was not doubling this in my head, that was Google. And then by the end, you just have a whole load of really big numbers, and if you want to work out how many grains of rice on the chessboard, does anyone want to add up like the first 2 rows? Because if you're willing to, I'll be very impressed, and then might get annoyed and not give this talk. But I doubt someone's going to do this very nicely, and it's quite painful just to find out the numbers. But you can write it like this: 2 to the 0, which is 1, and 2 to the 1, which is 2, and then 2 to the 2, which is 4. And so basically now all you need to be able to do is count to 63. And this is showing a geometric series. And so to find the sum of the grains on the chessboard, you need to find the sum of the geometric series. So these are 2 equations. This is the lovely correct one, and this is the one my teacher used, which is saying that you add up 2 to the I, and you start when I doesn't equal 0, 1 equals 1. I did have a presentation for this until I realised there was no screen and had to write this out 5 minutes before the talk started. It's great. So this equation is saying you start with 2 to the power of 1, and you add it up with 2 to the power of 1 plus 2 to the power of 2, until your last thing is 2 to the power of 64. This is saying 2 to the power of 0, but going on until you reach 2 to the power of 63. But there's a nice way to do that, and that's binary. So how many of you are in primary school? Can you put up your hands? When you add numbers up, do you look at hundreds, tens, and units? Do you? Okay. And so if I wanted to add up 13 and 42, I'd say, okay, I've got 3 units plus 2 units, that's 5. And then I've got 1 tenth plus 4 tenths, so that's also 5. But it's 5 lots of 10, so that's 50. And 5 lots of units, so that's 5. Yeah. So this is what's called base 10. You have units and tens and hundreds. And when you count in base 10, you go, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sure this is another thing you do already, by the way. I'm not. But then you run out of digits. You've got 10 symbols, and you say, okay, what do I do? So you say, okay, I'll put 1 in the tens column, and then 0 here, and I'll keep counting. And then I'll get to 99, and then I'll go, okay, I've run out on both sides. I put a 0 here, but then I've got 9 plus 1, so I've got to do the same thing again until I've got 100. But when we count in binary, we say, okay, 0, 1, but we've used up our 2 symbols. Binary only has 0 and 1. And so then we say, okay, I'll put 1 here, 0 here. So this, in how we normally count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We flip this later, but in binary we flip it at 2. So we have a 1's column, a 2's column, and then we go 3. Okay, I've got to flip again. And now we're in the 4's column. We have 1s and 2s 1 on the first, and 2 on the next square, and 4 on the next. We can keep counting like this. If that is right, which I'm really hoping I do. We get 8s, and then if I kept going, I'd get 16s, and you can add these up. So if I have my 1, and I want to add it to my 2, and I want to add that to my 4, we've got, let's write it out like this, like we would do if we had tens and units. If I want to add up my 1, and my 2, and my 4, we get 4 plus 2 plus 1. And so we get a nice line of 1s. But if I add 1 to this, then I get 1, 0, 0, 0, which is my 8. So we can see that if you have a line of 1s, and then you add 1, they all flip over like dominoes, and you get a 1 followed by a whole load of zeros. So this is the same as our chessboard. If I made this really, really long, which I'm not going to do because it would be wide and then I'd have to use more paper and it's very bad for the environment, then I would have a whole load of 1s with 2 to the 63, which is a big number, and 2 to the 62 and 2 to the 61. And I'd have all these 1s, and then when I add 1, I get 2 to the 64. So that means that my sum of all of the things on the chessboard is 2 to the 64 take away 1. Because you have all those 1s of your 1 and your 2 and your 4 and your 8 and your 16 and your 32. And then I flip them all when I add that 1. So if we unflip them to get what we are trying to add up, we get 2 to the 64. Take 1. And then all you need to do is rotate to the 64, which is obviously 1, 8, 4, 4, 6, 7, 4, 4, 0, 7, 3, 7, 0, 9, 5, 5, 1, 6, 1, 6. And take away 1, which I'm sure you can do.